This video is on circuits and Kirchoff's laws. Question 1. State Kirchoff's loop rule. Which conservation rule does this law obey? Kirchoff's loop rule tells us that the total voltage in a closed loop is 0 volts. This rule obeys the law of conservation of energy. So let's take a look at this outer circle here in this circuit. We'll have plus the voltage of the battery minus the voltage drop through resistor 1 minus the voltage drop through resistor 4 is 0 volts. Now let's take a look at this loop on the left side here. It's going to be plus voltage battery minus voltage drop through resistor 1 minus voltage drop through resistor 2 minus voltage drop through resistor 3 is 0 volts. Now let's take a look at this right loop here. It's going to be minus voltage drop through resistor 2 minus voltage drop through resistor 3 plus voltage drop through resistor 4 is 0 volts. Now why did I put a plus here? It's because I'm going in the opposite direction as current. Question 2. State Kirchoff's junction rule. Which conservation rule does this law obey? So the total current coming into a junction is equal to the total current leaving the junction. In a junction, total current in equals total current out. This obeys the law of conservation of charge. So in this circuit here, we have two junctions, the blue one and the red one. A junction is where two or more wires cross. So we have I battery equals I1. That means the total current going through the battery is the total current going through resistor 1. And I2 equals I3. That means the total current going through resistor 2 equals the total current going through resistor 3. So the blue junction tells us IB equals I1 equals I2 plus I4. Or I3 plus I4. And look at the red junction. It's going to be I2 plus I4 equals I battery, or I2 plus I4 equals I1, or I3 plus I4 equals I battery, or I3 plus I4 equals I1. So in the blue junction here, some of the current splits off into into I2 and I4, and in the red junction the current adds up. So these green lines are the direction of current. Question 3. Resistors in series have the same current. So here are some examples. In this first image, I2 equals I3, that means the current going through resistor 2 equals the current going through resistor 3, and IB equals I1, meaning the current going through the battery equals the current going through resistor 1. And I1 equals I2 equals I3 on the bottom image, that means the current going through resistor 1 equals the current going through resistor 2 equals the current going through resistor 3. Question 4. Resistors in parallel have the same voltage drop. So if you take a look at this image on the top left, we're going to have the battery and resistor 1 in parallel with resistor 2 and resistor 3, and that's in parallel with resistor 4. So you can see they all have the same voltage drop here. VB minus V1 equals V2 plus V3 equals V4, because the battery gives us a plus voltage and the resistors give us a minus voltage. Here, voltage battery equals voltage 1 equals a voltage drop through resistor 2 equals a voltage drop through resistor 3. And there is no resistor 4, so this is a mistake. Question 5, how can we simplify many resistors in series? You just add them up. So what does that mean? That means we could take these 3 resistors in series and make it look like one resistor instead of buying 3 different resistors. Question 6, how can we simplify many resistors in parallel? We just add up their inverses, and then in the end we just take the inverse of that. So instead of buying 3 resistors, we could just buy 1. And it's going to have this as a resistance. Question 7. 6 2.202 volt cells are connected in series. What will be the total EMF produced? Well, we could just add them up, their potential differences. Question 8. What will be the EMF produced by 4 1.5 volt cells connected in series? Well, they're in series, so we can add up the potential differences. Question 9. What will be the EMF produced by 3 6-volt batteries connected in parallel? Well, they're in parallel, so we cannot add up their potential differences. It's just going to be 6 volts. Question 10. What will be the EMF produced by the combination of cells below? So you see we got positive, negative, positive, negative, negative, positive. So it's going to be 4 plus 6 minus 3. So we're never going to actually physically put cells like this. Question 11. What will be the EMF produced by the combinations of cells below? So you see the 2 cells in parallel, they're both 4.5 volts. So we just say it's 4.5 volts because they're in parallel. And we add it up to the 2.5 volt because now it's going to be in series if we simplify the 2 in parallel. Question 12. Solve for the unknowns, give your answers in reduced fractions. So check this out. We have the resistance of the 3 resistors and the voltage of the battery. Now we want to find these unknowns, these 8 unknowns. So let's solve for R equivalent first. We could simplify these 3 resistors in series by just adding up the resistances. So it's 12 ohms. So now we have this 1 battery and 3 resistors. We have the circuit look like this now. 1 battery, 1 resistor. So we're going to use the loop rule to determine the current flowing through the battery and resistors. So remember, the loop rule tells us that the total voltage in a loop is 0 volts. So it's going to be VB minus VR1 minus VR2 minus VR3 is 0, which is this. What is V equal to? It's equal to IR. That's Ohm's law. Since they're all in series, they all have the same current. So now we could just factor out the I. This is the current flowing through the battery and all the resistors, 5 over 6 amps. Now we know V equals IR, so now we could just plug V1 equals I1R1, V2 equals I2R2, V3 equals I3R3. And if we add up these 3 voltages, it should equal 10 volts, which is the same voltage of the battery. So what happens to the current leaving the battery if the number of resistors in series increases? The current will decrease because we get more resistance. Now what happens to the overall resistance if the number of resistors in series increases? We're going to get more resistance. Question 13. Solve for the unknowns. Give your answers in reduced fractions. So question 12, we had 3 resistors in series. Now we have 3 resistors in parallel. So we're given this information, and we have to solve for these 8 unknowns. So first things first, let's solve for R equivalent. So these 3 resistors are in parallel to each other. So we have this equation. The second line, we're finding the same denominator. We're finding the common denominator. So everything in parentheses is equal to 1 because we could multiply it by 1. And then we have only one fraction on the right-hand side, and we're going to take the inverse of both sides. So instead of having 3 resistors in parallel, we could just simplify to 1 resistor. Now we have this. So if we have V, which is 10, which is given to us, if we have R, which is what we just solved for here, we could find I, the current going through the battery. It's this. So step 2, we're going to use a loop rule 3 times to find the current going through each resistor. So this is loop 1, this is loop 2, and this is loop 3. So I'm looking at the original circuit. Loop 1 is V battery minus V1. Loop 2 is V battery minus V2. And the biggest loop is V battery minus V resistor 3. That's how I got these 3 equations here. And finally this. So the current flowing through resistor 1 is 5 amperes. The current flowing through resistance 2 is 5 over 2 amperes. And the current flowing through resistor 3 is 5 over 3 amperes. So we could add up all of these currents, and we could get the current going through the battery, which is 55 over 6 amperes. And we could use the loop rule 3 times to find the voltage drop through each resistor. And remember, resistors in parallel have the same voltage drop. So you can see they're all 10 volts. So these 2 questions are important conceptually. What happens to the current leaving the battery if the number of resistors in parallel increases? The current increases. What happens to the resistance of the circuit if the number of resistors in parallel increases? The resistance decreases. Question 14, solve for the unknowns, give your answers in reduced fractions. So we have this circuit. Why don't we solve for R equivalent first? So we could simplify R2 and R3, which is going to be 2 ohms plus 4 ohms, which is 6 ohms. Then these 2 resistors, R2 and R3, become 1 resistor. Then R23 is in parallel with R4, so then we could simplify that. And then when we simplify R2, 3, 4 into 1 resistor, then we could simplify it with resistor 1, because that's in series. So let's see what I'm talking about. So step 1, find R equivalent for R2 and R3, which is 10 ohms. Step 2, simplify R2, 3 and R4. They're parallel with each other. And then finally simplify resistors R2, 3, 4 and R1, which is this. Now we have a circuit with 1 battery and 1 resistor. So now we could use Ohm's law. Sorry. Now we could use the loop rule from Kirchoff's law to find the current going through the battery. The current going through the battery is 45 over 29 amps. So now let's use the loop rule to calculate the current going through resistors R2 and R3. Okay. So V battery minus VR1 minus VR2 minus VR3 is 0. And we know V equals IR. So we could solve for I2, which is equal to I3. Now we could use a loop rule again, the outer loop, to calculate the current going through resistor 4. V battery minus VR1 minus VR4 is 0. That's the first line. The second line, we know V equals IR. And then we could solve for I4. Now we could use the equation V equals IR to calculate the voltage drop through resistor 1, resistor 2, resistor 3, and resistor 4. So V equals IR. We know I because we solved for it. We know R because we were given it. Question 15, solve for the unknowns, give your answer in reduced fractions. So we got 3 batteries here. And there's many different ways of solving this. I did it one way, you could do it another way. I'm just going to assume that current is going to go up through V2, and then it's going to go down through V1 and down through V3. And I'm going to use Kirchoff's law. I could use the loop rule 3 times because I have 3 loops. The left loop, the right loop, and the outer loop. And I have 2 junctions. So this is what I'm assuming here. And I apologize. I'm assuming that the current is going to go down through V2. So let's take a look at loop 1. It's going to be plus VB1 minus VR1 minus VB2 plus VR2 equals 0 volts. Now, understand where I got the plus signs and the minus signs. I'm starting from the bottom of battery 1 with a negative sign. Then I'm going up, so I get plus VB1 minus VR1 and now I'm saying minus VB2 because I'm going against the battery. Plus VR2 equals 0 volts. Okay. So I end up getting this equation in yellow. 2 unknowns, I1 and I2. Let's take a look at loop 2. I'm going to start here from the bottom of V3 plus V battery 3 minus VR3, which is here, minus V2 plus VR2 equals 0 volts. I know V equals IR and I could simplify to get this. So my first 2 yellow equations, I have 2 equations, 3 unknowns. I don't know I1, I2, and I3. I could use a junction rule here on the top. I1 plus I3 equals I2. Now I have 3 equations, 3 unknowns. Now let me go online. Let me put these numbers into a matrix calculator and I get these solutions. So I1 is minus 9 over 5, I2 is minus 2 over 5, and I3 is plus 7 over 5. What does a negative sign mean? It means that the current is moving in the opposite direction. Question 16, solve for the unknowns, give your answers in reduced fractions. So you know what we're going to do. We're going to simplify R2 and R3, then we're going to simplify R4 and R5, then we're going to simplify those in parallel, then we're going to simplify R1 with R2, 3, 4, 5, and R6 because they're in series. So I didn't do this problem for you, but you know how to do it because you've done the previous problems. Here's another problem. Solve for the unknowns, give your answers in reduced fractions. So you could simplify R4, R5, R6 in series. You just add up the resistance. Then R2 is in parallel with R4, 5, 6, so you could add them up in parallel. And then R1 and R1 and R2, 4, 5, 6 and R3 are in series with each other, so you could add them in series to find our equivalent. I did not do that problem for you. Question 18, the image below shows a circuit with 2 resistors X and Y with the resistance R and 2 cells with negligible internal resistance. Use Kirchoff's laws to calculate the current through each resistor and cell. So I had to make an assumption, and this is the assumption that I made, the direction of the current. So let me use the loop rule for the left loop. Plus E minus V sub X minus V sub Y is 0. We know V equals IR. Let's take a look at the loop on the right. This is plus 2E minus V sub Y equals 0. And we know V equals IR. So now let's use this junction rule for the top junction. I1 plus I2 equals I3. So here I wrote equation 1 and equation 2 again, which is here. I inserted equation 2 into equation 1 to get this. So now the negative sign means that the current is moving in the opposite direction. We're going to use equation 1 and substitute I1. So now I get this. Finally, we're going to use equation 1. This is equation 3. Solve for I2 to get this. I2 is 3E over R. Question 19, what is a potential divider or a voltage divider? A voltage divider circuit is a very common circuit that takes a higher voltage and converts it to a lower one by using a pair of resistors. So we could have, without this resistor in red, two resistors in series. Once we add this resistor in parallel, it's going to decrease the voltage drop.